Hello and welcome to today's class. Today let us learn about polynomials. Polynomials is derived from Greek words poly and nominals, where poly means many and nominals means terms. So together we can say polynomial means many terms. Coming to the definition of polynomial, it is an expression which is composed of variables, constants, exponents, and they are all combined using mathematical operations such as addition and subtraction, etc. So here we will look at this example. Here x is the variable. In first term, x is raised to power 2, that is the exponent is 2. Then there is subtraction sign. Then x is raised to power 1 in term 2. The constants with variables are known as coefficients. So 8 and 5 are coefficients here, and 6 is constant, and there is addition sign. So all together, this is an expression which has mathematical, which the terms are combined using mathematical operations here. So now let us try to understand degree of polynomial. In a polynomial p of x, the highest power of x is known as degree of polynomial. Let us try to understand this with an example. Okay. So first example is 8. First question you get is 8 even a polynomial? Yes, it is. Don't forget that 8 can be written as 8 into x power 0, where x power 0 is nothing but 1. So what we can conclude from this is it is a polynomial of with the degree 0 because its power is 0. Highest power in this is 0. So the degree is 0 and it is known as 0 polynomial. Then coming to the second example, 2x plus 9. The power of x is what? 1. So it is linear polynomial and degree is 1. Then in this equation 4x square plus 8x plus 2, you might get confused because there are two powers of x in this equation, right? One is 2 and another one is 1. In the first term it is x square and the second term it is x. So you might get confused. So remember that the degree of the polynomial is that with highest power. The highest power of x is degree of the polynomial. So what is greater, 2 or 1? 2, right? So the degree of the polynomial is 2. Similarly, if you go for cubic polynomial, here the highest power of x is 3. So the degree of the polynomial is 3. And in quadratic polynomial, the degree is 4 because highest power of x in quadratic polynomial is 4. Coming to zeros of a polynomial, if in a polynomial p of x, x is replaced by any real number k, and on replacing it, the value of p of k becomes 0. So basically what happens is, there is a simple, let us take an example and understand. There is an equation p of x is equal to 2x plus 3. Okay, now what you will do, you will replace x by some value k. You will replace it by some value k and the polynomial becomes 0. That is p of k is equal to 0. You equate it to 0. Then what we get is 2k plus 3 is equal to 0. Now on rearranging this, what will you get? Taking 3 this side, minus 3. 2k is equal to minus 3. Then what you do? K is equal to minus 3 by 2. So this is how you find the zeros of polynomial. I hope it's clear. It will become more clear as we see more examples. So now let us try to understand the geometrical meaning of zeros of a polynomial. Geometrically, zeros of a polynomial are the points where it cuts the x-axis. So in this first graph, we can say that the polynomial graph of the polynomial doesn't cut the x-axis at all. So what it implies is it has no zeros. But in this second equation, we can see it cuts the x-axis at one point which is minus 1 by 2. Don't get confused. The geometrical meaning is wherever it are the points wherever it cuts the x-axis, not the y-axis. So you have to concentrate only on the x-axis. Don't get confused with this. You can also verify if this is correct. Okay, because see, this is the equation 2x plus 1. On solving it, you'll how to solve it? You'll have to replace it by k first thing, and then you have to equate it to 0. Then what you'll write? Then on rearranging it, you get k is equal to minus 1 by 2. If you take 1 this side, and if you take 1 this side to the right hand side, and 2 you divide it, you'll get minus 1 by 2. So it is verified. Coming to quadratic polynomial, this is a polynomial x square. This is the graph of the polynomial y is equal to x square minus x minus 2. So in this also you can notice it cuts the x-axis at 2 points, at 2 and minus 1. So there are 2 zeros. Okay. Coming to different cases in a quadratic polynomial, it can either see what we can observe is when the parabola can cut the cut the x-axis at 2 points or 1 point or not at all. So this graph case 1 implies that there are 2 zeros. Okay, and case 2 implies there is only 1 zero, and case 3 implies it has no zeros because it doesn't cut the x-axis at all. So at most there can be 2 zeros of a quadratic polynomial. Coming to cubic polynomial, the curve of this polynomial is this, and it cuts the x-axis at 1, 2 and 3 points. So there are 3 zeros of this cubic polynomial. Again in this there can be 3 cases. So first case it cuts at 3 points. Okay, and second case it cuts at only 1 point, that is origin here, and here it cuts at 2 different points. So at what we can conclude from this is at most a cubic polynomial can have 3 zeros. From our observation, like based on quadratic polynomial, linear polynomial and cubic polynomial, what we can decide is that if there is a polynomial of power n, degree n, then the number of zeros can be n, at most can be n. Total number of zeros at most can be n, because see cubic polynomial, in cubic polynomial there are, the degree is 3 and at most it can have 3 zeros. Now let us try to understand using these graphs, using these examples. Here in the first graph, it cuts the x-axis at only 1 point. See, here. So there is only 1 zero. But in the second graph, here it cuts the x-axis at 2 points. So there are 2 zeros. Similarly, in this graph, it cuts the x-axis at 1, 2 and 3. 3 points. So there are 3 zeros. In this fourth one, it cuts the x-axis at only 1 point. So 1 0. Here also it cuts only at 1 point, 1 0. And last graph, it cuts at 1, 2, 3 and 4 points. So there will be 4 zeros. I hope this is clear. So this is the solution of the previous example. Thank you.